What we're going to do is we're going to look at how our Le Chatelier principle can be interpreted in terms of changing concentration in the lab that we're going to do. So the first thing we can do is, when we're looking at the addition of something, is look to see if it's in our original equilibrium. And if it is, then we can apply Le Chatelier as we've talked about already. But if it's not in the initial equilibrium, then what we have to do is see if the entity or the thing added will interact with one of the ions in my main equilibrium, and in doing so form a secondary equilibrium. If it does, then we have to identify it. We have to provide our balanced equation. Then we'll talk about how it affects the main equilibrium and how the main equilibrium would then shift in response to that. And then we'll tie the shift and everything into the observations that we made. So for example, we set up this equilibrium where we place 10 drops of copper 2 nitrate with 10 drops of sodium chloride. Now we know nitrate ions and sodium ions, they're soluble with everything, so we can ignore them. And we end up with our net ionic equation, but it's an equilibrium where my copper 2 ions will combine with chloride ions to form what's called a complex ion that has a brown color. So what we're going to do is we're going to see what happens when I add a variety of different things to it. So for the first case, what we're doing is we're adding NaCl. Again, NaCl, we know that it has sodium ion and chloride ion. We would never look at the impact of a sodium ion on the equilibrium because sodium is soluble with everything, and so rarely will it affect my equilibrium. But what we notice is that chloride ion is in my original equilibrium, and so as a result, the addition of sodium chloride to my solution would actually increase the concentration of my chloride ion. And so as a result, my main equilibrium will shift in the forward direction to consume some of my chloride ion and partially decrease it. So this is straightforward, where we add an entity that's in our original equilibrium. Okay. When it shifts forward, it's going to produce more of my complex ion, which will generate a greater brown color. So now that ties it back to our observation. What about when we're adding something to our equilibrium or a system at equilibrium that's not in it? For example, we're adding sodium chloride. Again, sodium hydroxide. Sodium hydroxide, we know, will dissociate completely into sodium ions and hydroxide ions. Again, sodium ions, because they're group 1, we can ignore them. So now the question is, does my hydroxide ion interact with anything that's in my main equilibrium? And so what we can do is we can bring up our solubility table and we can look for our hydroxide, and we see most. And so we can see that copper 2 ion will form an insoluble precipitate with my sodium ion. So therefore, what we can say is that the added sodium ion would combine with my copper 2 ion to form a white precipitate in the secondary equilibrium. So now I'm stating what the thing added to will interact with in my main equilibrium. Now I'm going to give the equation for this interaction. And because it's a slightly soluble salt where it has low precipitation, whereas last year for the formation of precipitates we gave a one-way arrow, this year we're going to understand that they actually establish an equilibrium. And so we'll write down my secondary equilibrium. And so as a result, this is going to cause the concentration of my copper 2 ion in my main equilibrium to decrease, because the copper 2 ion is now being involved in a secondary reaction. So this allows me to now identify my stress, right? So my stress is going to be the decrease of the copper 2 ion. And so as a result, we know that it's going to shift in reverse to produce some copper 2 ion. And so my main equilibrium will shift left, dissociating some of my complex ion. So I'm going to have less of this formed. And so as a result, that ties with it being less brown. And when I shift to the left, I'm going to produce more copper 2 ion, which ties into it being more blue, and will partially increase the concentration of my copper 2 ion. Let's take a look at a second example. In this case, I'm going to add lead 2 nitrate to my solution. And again, it becomes less brown, but in this case, I get a yellow precipitate. So again, I'm going to look at my lead 2 nitrate, and I know that because nitrate is soluble with everything, it's going to dissociate into lead 2 ions, nitrate ions. Nitrate I'm going to ignore. So now the question is, does my lead 2 interact with anything? So again, we'd pull up our solubility table, we'd look for a chloride, we'd see lead 2, low solubility. So again, that means that it's going to establish a secondary equilibrium. And so we can say that my lead 2 ion will combine with my chloride ion to form a yellow precipitate in a secondary equilibrium. Now, you may not necessarily know the color of all the precipitates, but we can help to tie it back to our observations. Okay, and so now I stated what the thing I added is going to interact with in my main equilibrium. I'm going to give the equation for the secondary equilibrium. Again, for any slightly soluble salts, we're going to say that they form an equilibrium rather than a one-way arrow. And as a result of my chloride ion being involved in secondary equilibrium, its concentration is going to decrease in my main equilibrium. So now again, we can identify our stress, which will be the decrease in chloride ion. And so again, my main equilibrium will shift to the left. When it shifts to the left, I will get again a dissociation of my complex ion, which will decrease the amount of brown, and I'll produce some more chloride. And at the same time, I'll also produce some more copper 2 ion, which will tie into being more blue. And so we can see the impact of adding additional things to our main equilibrium. Finally, one more example. I take my zinc 2 chloride and I combine it with NaOH and I establish a equilibrium. Now, in this case, what would happen? Okay, white precipitate. What would happen if I add NH3? And I find NH3 forms a purple. When it's added, I get a purple color and less precipitate. So right away, even before I start, the only way that my NH3 could cause less precipitate is if it reacted with one of my 2 ions. So we can look on our chart with our complex ions, which you are being provided with for the lab, and we will see that my ammonium will combine with my zinc ion to form a complex ion in a secondary equilibrium. And on the sheet, it also tells us that this new complex ion that's being formed has a purple color. And so as a result of this establishment of a secondary equilibrium, our concentration of our zinc 2 ion is going to decrease in my main equilibrium. And so therefore, we can now identify our stress. And so once we know our stress in our main equilibrium, we know that it's going to shift in a reverse direction. And when it does this, it will produce more zinc 2 ion to partially increase the concentration of my zinc ion.